In the previous lecture, we have started with the joint probability function for the discrete random variable. The joint probability function for the discrete random variable represents the two different symbols. One of them is a random variable denoted by x, other is a random variable which is denoted by y. So it is a combination together to be taken always for the random variable x as well as y. So its corresponding probability function is defined by small f of xy. So in the previous question, it was the function was given to you as c into x into y, and values were given for x as well as corresponding values for y. Similarly, this is also a particular example. See, for before this, whenever we have discussed about identification of the continuous random variable, I have many times told you that it should be the interval or the splitted form. So you may not confuse here, though the values are given here in the splitted interval form, but what is mentioned in the question, how are the random variables over here? The random variables over here are discrete random variables. So another way of representing the discrete random variable can be in the interval form, but it is less than or equal to. So that means these values are all inclusive values. So always read the question carefully. The joint probability function of two discrete random variables x and y. So though the function you observe in the interval form or in the splitted interval form, but still this is not a question of continuous random variable, it is an example of discrete random variable. So how is the joint probability function defined by? Joint probability function is defined by c into 2x plus y, 0 less than equal to x less than 2, 0 less than equal to y less than equal to 3, 0 otherwise. What you have to calculate here? We have to calculate the value of c, we have to calculate the value at probability x equal to 2, y equal to 1, probability x greater than equal to 1, y less than equal to 2, marginal probability function of x and y, and lastly we have to check whether x and y are independent or not. So we initially, with the help of the given function and the corresponding values, we try to find out the joint probability table. So x की value कहाँ से कहाँ तक है? 0, 1 and 2. So in the row we calculate the or take the value of x as 0, 1, 2. In the column form we take the value of y as 0, 1, 2, 3. Now what is the function? C into 2x plus y. Calculate how it will be 0, 0. For 0, 0 the function will be 0 plus 0 into c. That will be 0. Function will be for x equal to 0 and y is equal to 1. So 0 plus 1 is 1. So 1 into c will be c. So 0, 2. X is 0, y is equal to 2. 0 plus 2 is 2. 2 into c is 2c. X equal to 0, y is equal to 3. 0 plus 3 is 3. So 3 into c is 3c. The summation of all this is giving you answer as 6c. So similarly x2 and y1. 1, 0. So it will be 1, 0 कैसे आएगा? 2 plus 0 is 2. 2 into c is 2c. This will be 3c, 4c, 5c. Accordingly, summation after taking the sum of all the entries in a corresponding row, it is giving you 14c. This is giving you 4c, 5c, 6c. 2, 3. 2 2s are 4. 4 plus 3 is 7. 7 into c is 7c. So accordingly, you are getting the answer over here as 22c. So similarly, here we get the answer as 22c. So 6c, 14c, and 22c are corresponding the corresponding the sum of the entries in the row, and these are referred as, or these are called as, marginal probability functions of x. Similarly, the addition of the column 0 plus 2c plus 4c is 6c, 9c, 12c, 15c. These are identified as marginal probability functions of y. I told you horizontally and vertically, the addition, whatever it is coming out, it should always be equal and it is equated with 1. So 6 plus 14 is 20. 20 plus 22 is 42. Similarly, here also, if you add them together, your answer will always come out as 42c. So for obtaining the value of constant c, since f of xy is a joint probability function, summation over x, summation over y, f of xy is equal to grand total 1. So 42c is equal to 1 and c is equal to 1 upon 42. So c is equal to क्या हो रहा है? The value of c is coming out as 1 upon 42. Now your function is defined as 1 upon 42 into 2x plus y. Clear? This is how our function is now finally the joint distribution function or joint probability function. For x equal to 2 and y equal to 1. See the table. For x is equal to 2 and y is equal to 1. How it is equal to? For x equal to 2 and y equal to 1, the value is 5c. So we calculate the answer for 5c. It is 5 upon 42, which will be giving you the answer for the probability x equal to 2 and y is equal to 1. Now, what is the probability for x greater than equal to 1 and y less than or equal to 2? Now, what are the values of x they are taking? Greater than equal to 1. Means what are the values available for x greater than equal to 1? The values available for x greater than equal to 1 are x equal to 1 and x equal to 2. But y up to कहां तक लेना है? Y up to 2 तक लेना है. Less than or equal to 2 means I will be calculating only values up to this. So how it is going? This is what the answer should be. So for I will be adding them together. 2 plus 3 plus 4 plus 4 plus 5 plus 6. So it is giving you almost the answer as 2 plus 3 plus 4, 4 plus 5 plus 6. Accordingly, it is giving you the answer as 24c. And what is 24c? 24c is 24 upon 42. That is giving you the answer as 4 by 7. I hope you understand this. X greater than equal to 1 means 1 and 2, the highest value of x what it can take. And y should be less than or equal to 2 means y should be moving from 0 to 2. So only this particular box comes into the picture. This is the box which is into the picture for the calculation. You add them together. Do not directly blindly take these values because these are addition of all the rows. यहाँ पर पूरे values नहीं पूछे हैं. Only we will be dealing with 2 plus 3 5, 5 plus 4 9, 9 plus 11 is 20 and 20 plus 4 is 24c. So this is what 24c we are getting. 24 upon 42 is 4 by 7. Now nextly what we have to calculate? We have to calculate the marginal probability function for x. The marginal probability function for x is correspondingly given by 6c, 14c and 22c. So write down the values. It is 6c, 14c, 22c. 6 by 42 is 1 by 7. 14 by 42 is 1 by 3. 22 by 42 is 11 by 21. This is for x equal to 0, x equal to 1, x equal to 2. In the previous example, you have seen we have taken the LCM over here. But here it is not possible for us to generalize it. We keep the answer as it is. Here also, what are the values present in the bottom row? 6c, 9c, 12c, 15c. So accordingly, I will be calculating 6c, 9c, 12c, 15c divided by 42. Accordingly, you get the value corresponding probability function for y equal to 0, y equal to 1, y equal to 2 and y equal to 3. So this is what the second part of the question what they have asked is find the marginal probability function for x and marginal probability function for y. The last part what they have asked is are x and y independent? Now check what is your probability function, joint probability function. It is 1 by 42 2x plus y. You take any value of x and y. For that particular quantity, it should satisfy LHS as well as RHS. Abhi, one more quantity is remaining or what? Additionally, what they have calculated here, probability at x equal to 2 and y equal to 3. Yes, what we are trying to show here is probability at x equal to 2 and y equal to 3. It is giving you answer as 1 by 6. Probability at x equal to 2 and all values of y. It is giving you the probability as 11 by 12. and if you put it into the individual product, this individual product is not equal to that particular joint probability function. This is individual probabilities what we have calculated, and I have taken the product. This is the common function. This is the common function, 1 by 42 into 2x plus y. So what I have taken over here, I have taken the value of x as 2. 2 2s are 4 plus 3, 7. 7 by 42 is 1 by 6. This is the original probability function f of xy. Now individually I will be calculating the value for x equal to 2 and all values of y. For y is equal to 3 and all values of x. This product is not equal to 1 by 6. So therefore I say that x and y are not independent random variables. Here we see that x and y are dependent on each other. In the previous example, there we got the combination in the generalized form, and hence we were in a position to write down that yes, x and y are independent random variable. So this is also one of the example where we can discuss or say that yes, x and y are not independent random variables. So that was the example related to the joint distribution or joint probability function for discrete random variable. The other example which shows